So compound interest is more common. And compound interest, we talked about simple interest just being an interest rate keeps getting applied to the original amount. It's a really easy formula. Compound interest more typical because you get your interest, but as soon as you're either paying interest or get charged interest, then they start charging you or giving you interest on your interest as well, which is what the word compound means. Things grow faster, you also get charged more faster. The compounding period is the time interval for which compound interest is calculated. So we're going to look at the difference between simple interest here, right? You have $10,000. If you got 2.1% interest, you get $210. And the amount at the end of the year would be $10,210. So that's how much you're starting with. But in compound interest, the idea is, well, now you still use your simple interest formula, but it's now based on the new amount. And now you would get an extra $4 of interest because you have extra money in your account. And so at the end of the year, you have more. Then the start of the next year, you start with more. Now, instead of getting 210 or 214, now it's already up to $218.91. And so the amount at the end of the year is even more. And we can do this for one more year. And at the end of 4 years, you actually have $26.83 more than if you just got simple interest along the way. And I think somebody in our class even mentioned, well, why wouldn't at the end of the year, why would you just stick with the 10,000? Why not start it again new and make more money? And then that's the idea. But instead of you having to do that, it's already pre-calculated with the bank. The bank says, we're doing compound interest for you. So as soon as you make money, it automatically is reinvested into your account and becomes your new principal. And you make money on that. So the idea of simple interest still happens, but that simple interest is now based on a new amount, and a new amount, and a new amount. And is there a mathematical formula to go right from here to here? Absolutely. It's a little bit more complicated. But
P1 plus R over N.
to the there you go, he's got it. Everybody good? Not yet? I'm gonna have to expect you guys to be a little quicker too.
Bestia, ¿puedes explicar otra vez, por favor?
Comienza con 10,000, ¿no?
10,000.
10,000, 2.1%. El fin del año. Próximo año ya tiene más. Entonces ganas más. Porque 2.1% de 10,000, 210. Y ahora es 214 porque tiene más el comienzo del año. ¿Ok? El fin de año ya tiene más. Comienzo del próximo año tiene más, entonces vas a ganar más. Y este es compound interest. I don't know how to say compound interest in Spanish.
Mr. Roboto. How do you say compound interest?
How do you say compound interest in Spanish?
Compa?
Esto en español. Interest? Do you know how to say interest in Spanish? Interés.
Interest.
Now I think,
Compound interest.
there we go. Now you're sounding more Italian. That doesn't quite work.
It's true. It's true. It didn't take long to go Italian, I guess.
Here is the formula for compound interest.
Igor's in deep thought about that. Formula.
Are you writing? Where's your notes? You lost?
Yeah, lost.
Oh,
I should have made I should have made for these notes 10 extra copies. I made like 9 extra copies. I'm all out. Even my copy gone.
After the brackets, is that an exponent 11?
Yeah.
After the brackets? Or is that, I can't.
There's, yeah. Okay.
Okay, after the brackets, what is that? I can't see.
This as a little n.
Okay.
Wait, so let me see here.
And
The top for me is like blurry, so it looks like a 11.
this is the compound interest. Yeah, it kind of looks like 11. I can see
So
that.
wait, which is
It's a
your,
little n.
which is your?
Yeah.
Is the compound interest like adding like throughout like time?
That means throughout time, your interest gets added and they calculate it with interest. I know you're looking at it. This is only the formula if it's calculated once a year. We're gonna get another formula later with the MT. So we plug, the question is, if you're given a formula, can you plug things into a formula? Can you type them into your calculator? So what do we know? We know that our principal is 10,000. We know our interest rate as a decimal, we can change it, and the n in this case, n years, is 4 years. Could we plug everything in? Absolutely. Oh, I do have one extra. Awesome.
I want to ride my bicycle. I want to drive my bike.
Yeah, I know that.
I want to ride my bicycle.
Someone's getting excited for the warm weather.
Oh, yeah. This Leo baby is ready for the sun. The Weather Network, honestly, must be the greatest job on planet Earth. You literally can be wrong 80% of the time and still be doing your job.
I know. Good.
What's the best job in the world?
I actually
How
want
do
to
you
just
become
be.
a weatherman?
I just want to be the guy that does the 7-day one. Because that's the one you can screw up, and
You
the
can screw up.
6-day guy will fix it,
Yeah, well, totally.
right?
Exactly.
Just make up a bunch of complicated formulas.
I want to, I'm gonna Google after this later today. I'm gonna find out what's the path to becoming a weatherman.
Yeah.
Maybe
The formula.
meteorology.
The formula for the 7-day
Maybe.
forecast is you take the 5-day forecaster from the day before, you roll a dice, you get a high number, temperatures going up.
Yep.
Hostia,
1 to 3, temperatures going down,
Oh, yeah.
right?
hostia.
Up 3, down 3. Right? Roll the dice again, how much you're gonna go up or down, right? You wanna create a little bit of a buzz,
Little brain, 40%
make it
chance.
higher.
¿Qué dice la R? No entendí qué se refiere.
¿Qué dice aquí?
En la R.
But it's okay because I
The
put
N
it
En
in.
la
es
en la
40%
The-
chance.
It's the interest rate.
So
It's-
Mr. Sure, I think to do that, I
Aquí.
think like meteorology stuff like that.
Maybe, but they don't know.
It's
a
the
whole lot.
it's the percentage as a decimal. We always have to divide by 100 to get a decimal.
That's good.
¿Y cómo lo puedo diferenciar entre los demás?
That's 2.1% está igual. ¿No ve? 1, 2.
Bike rides this summer, yeah.
Oh.
Siempre ese.
They don't know any of the ones that do that.
Okay.
Okay. All right. I'm going to skip with you guys. Example 2, example 3. And we're going to go to the chart to get us ready for the more common compound interest formula. In fact, you can use the more common one all the time. So we can kind of skip that first formula. We did it as an easy example. But when interest is compounded, the compounding period refers to how often it's added. When you open a bank account, people are impatient. You don't want to wait a whole year to get money. You're much more, if they give it to you at the end of every month, you get more excited. So if they owed you $12 at the end of the year, they said instead of giving you $12 at the end of the year, we'll give you $1 every month. Makes sense? It's still $12 over the whole year, but you get your money quicker. And when you get your money quicker, they're like, oh, since we gave you an extra dollar at the end of the month, I guess we can give you some more interest because you have that extra dollar. And then end of month 2, they give you $1.05. And you make a few more cents.
That's fine.
So, if we compound annually, that's happening once a year. If you see that it's compounded semi-annually, that happens twice a year. Okay? Semi-annually is what happens with mortgages. Did you know that the amount of money that you pay on your mortgage is only compounded twice? It's set as a law in Canada. I believe it's a law in Canada. I don't know if it's the same. So you only get charged interest twice a year rather than multiple times, saving you a little bit of money, not a lot. As I told you yesterday, the number of compounding periods doesn't make a huge difference, but it does make a little difference. 4 times a year would be quarterly. If they say it's compounded monthly, that happens 12 times a year. What word's going to be under here if it happens 365 times a year?
Yearly,
Yearly?
daily.
Daily, there we go. If they compound interest daily, okay, so a loan shark would definitely be charging you interest daily because they want to take advantage of every little bit that they can make money off of you.
Plus the big.
So if your annual interest says you owe $365 a year, that's like owing $1 a day. But you owe $1 the first day. If you don't pay after the first day, they're saying, oh, next day you owe $1.02. And you're like, whatever. And then the next day $1.04. And you're like, whatever. But it adds up over time. Here is the most important compound interest formula. The other one I wouldn't even put on my formula sheet. I would just put this one on my cheat sheet for compound interest. This one adds n as the number of compounding periods. So if it says it's compounded monthly, both of the n's would change to 12. If it says it's compounded daily, both of your n's would change to 365.
Yeah. ¿Y qué significa la minita?
Esto?
Sí, la
The dot means multiplication.
no la derecha, la
Te?
Sí.
Te is aquí.
Oh.
Es tiempo en años.
Annuals. Yearly.
Year. All right, I'm gonna pause the video. That's not on the video.
Quizás.
That's a little small for you. I'll make it bigger.
Honestly, my favorite word might be quizás.
Here's the idea. So let's compare the $1,000 at an interest rate compounded semi-annually and compounded quarterly. So in quarterly, oh man, you're starting with $1,000. At an interest rate of 1.5%, you should get $15. Right. So if your interest rate is 6%, it's divided by 4, and you're getting 1.5% each section. If your interest rate is 6% and you divide it into 2 sections, you get 3% here and 3% there. So you have 1,015 at the end of 3 months. Because compounding quarterly means your year is split into 3-month sections 4 times. 3, 6, 9, and 12. At the end of 3 months, the bank says, here's your $15. Then you start month 4 with 1,015. Now you get an extra 23 cents. Then you start month 7 with this amount, and then you start month 9 or 10, last 3 months, and you end up with $1,061.37.
What?
You started with $1,000. You get interest along the way. They pay you interest every 3 months. Okay? So look at the difference. At the end of 6 months, you have $1,030.23. If they only compounded semi-annually, twice a year, then your interest is split up into 2. 3% and 3%. You start off with 1,000. 3% of 1,000 is $30. At the end of 6 months, you get 1,030. Notice at the end of 6 months here, you had 23 more cents. Not a lot, but a little bit more. So compounding more often will result in a bigger number, but comparatively, now at the end of the year on this one, now you get 1,060.90 cents. This one, you're up already 47 cents more. Not a lot. So the more compounding periods make a difference, but not a huge difference.
Yeah, I thought it was more.
Most people would think it's more and get scared when, and so for the most part, banks go, oh, we'll only charge you monthly. Those guys are charging you daily. That's enough to convince a person to switch, even though it doesn't cost them very much money.
And it could be a higher.
Right,
interest.
we'll charge you only monthly, but our interest rate's just 0.1 higher, not like,
Meanwhile,
that is huge. That would make the big difference.
so it really is all about the rate.
Yeah.
It's good to know. It's good to know. And Zuby, she didn't have braces before, did she? Is that new?
So you want to just check what this, if I do this one, change it a little bit, under 6.5%?
Well, that's double. What do you mean?
No, like instead of 6, this was 6%,
Oh,
cut up in half would be 3 and 3. If I do 6.5 total, cut it up in half would be 3.25 and 3.25. But if I do 6.5, changing that by 0.5%, change this by $6.
oh,
So 0.5% is already 6, like, we're talking about 47 cents when we change from 2 to 4, but adding 0.5% in this one would change by $6.
oh yeah.
Almost $6, $5.10.
Yeah, that's a.
So that's much bigger difference that can affect over time.
You write that down.
Yes. So if you have more compounding periods, what does it mean? Each period includes a little bit more principal to calculate interest. This causes the total amount to grow slightly faster, but not a ton. But over time, this could be significant. Like in a year, it didn't make a huge difference, but over 100 years, it would make quite a big difference. But again, the interest rate is the most important thing.
Yeah.
So when you're getting a loan from the bank, you want to see if you can get that interest rate as low as possible.
I could put my mortgage on 100-year mortgage, that'd be great.
Would and would, maybe. You're paying over a longer period of time, you pay a lot more for your house. We can figure that out on a
How
calculator.
much less per month? And how long you gonna live?
Alright. If we did the same thing and used the formula for monthly, okay, this is showing each thing separately. You never do it separately, you always use the formula. Here's our formula. If it was monthly, we'd put $1,000 in We put a 12 in for the N. We're doing it for 1 year. Interest rate is a decimal. Again, monthly is a little bit more again, but look at compared 1,061, 68, 1,000, like 31 cents more than quarterly. You think it would be a lot more,
I would have thought.
but it's just a little bit more. So Kevin opens an account with an interest rate of 1.8% per year, compounded monthly. So first of all, you read the question. You've got your formula on your formula sheet, on your cheat sheet. This will be on your cheat sheet, I hope.
CJ, can you go back
I am-
one slide? Can you go back one slide?
Yes, please.
What? You guys threw that whole story? You
I
didn't
don't
finish?
finish it for
No,
you.
because you had the calculator thing
Oh,
walking.
I had the calculator thing. Okay. All right.
In the bin.
I'm done all with this.
Nobody cares.
Just vicious.
Oh.
That was better.
Now.
Hey, don't you do pre-calculus?
I do grade 10 pre-calculus. I have all the videos online already. You can.
You should put me in
So
your
Okay,
any-
so next.
Yeah, you should put
next
me in your
yeah.
class.
So
Can you
next
put me
year,
too?
if I miss notes, I'm just gonna copy all of your videos.
You could, but they might have a little bit different note package, right?
Like, please.
So-
You should put me
The
in
first thing you're going to do in a question like this, you're going to read through it and say, okay, I know this is my formula, so I need to know each of these things. I need to know do I know the P? Do I know the R? Do I know the T? Do I know the N? The P is the principal, how much money you started with, $2,000. The R is the interest rate as a decimal, so I take 1.8% per year and divide that by 100 to get 0.018, which is just moving the decimal place over 2 spots to the left. The amount of time want to find out how much it's worth at the end of 5 years. And it's compounded monthly, so you know that the N is 12. You then go to your formula and you plug everything in for the letters. So we don't know the A, so it stays A because that's what we want to figure out. 2,000 for the P. We write the decimal for the R, the 12 for the N in 2 different places, and the 5 for the T. Oh, I'm actually going to. Right, that dot means multiplication. Because the N and the T together here in the formula means multiplying together. So it's going to be 12 times 5. I wrote the 12 first because in my formula I wrote the N first. Then this, you should have a good enough scientific calculator that you type this in exactly as you see it. And just push enter.
What about A though?
The A is what you typed in what's in the green box, exactly as you see it. And then you still have A equals, because that's what you're figuring out.
Wow.
That's more.
Which means Kevin will make
I want
$188.20
your other pencil.
for doing nothing. I love that. It's my favorite job in the world. Making money doing nothing.
Yeah, weird. It is. How do you
What about the
that?
O?
I got it right.